Okay, moving on to question number 4. What is the pH of 0.2 molar of ammonia solution at equilibrium if the Kb value for ammonia is 1.8 times 10 to the power of negative 5? So from here, you need to write the chemical equation first. So ammonia, NH3, because it's ammonia solution, you have H2O. So it's a reversible equation. So NH4 plus OH negative. So just make sure that this equilibrium is equation is balanced. So how many H that you have here is 3 plus 2, 5. So 4 plus 1 is 5. 1N, 1N, and 1O and 1O. So this one is balanced. So given in the question is a clue where you have the Kb. So when you have Kb or Ka, you need to write your ice diagram. So ICE. Okay, remember in your ice diagram, H2O doesn't play a role, so just ignore it. And then initially the concentration of ammonia is 0.2 as stated in the question. So at first is 0.2. And no product has been produced, so 0, 0. Eventually some of this ammonia will be dissociated, so 0.2 minus X, so this one is positive X, positive X. So at equilibrium is equivalent to 0.2 minus X, this one is X, and this one is X, right? So when you want to calculate your Kb, is whatever in the product, this is the product, right, divided by whatever in the reactant. Okay, given in the question is the value of your Kb. So Kb is 1.8 times 10 to the power of negative 5, equivalent to x squared divided by 0.2 minus x, right? So we are going to do the approximation because it's hard. So we are going to omit this x over here. So it's going to be 1.8 times 10 to the power of negative 5 is equivalent to x squared divided by 0.2, right? So you will get your x squared is actually equivalent to 1.8 times 10 to the power of negative 5 times 0.2. So you should get your x square should be equivalent to 3.6 times 10 to the power of negative 6. Therefore, your x is equivalent to square root of this. You will get 1.8974 times 10 to the power of negative 3. That is your value of x. So now you need to check the validity of this. So you need to do the test. It's equivalent to your value of x, 1.8974 times 10 to the power of negative 3 divided by the initial concentration, 0.2 times 100%. So you should get your test equivalent to 0.9487%, which is less than 5%. So this one is approved. Alright, since you get the value of x is approved, which is lower than 5%, means that we can use that value of x to use as the concentration of your OH. So again, I'm going to show you the ice diagram. So you have the NH3 plus H2O. You will produce NH4 plus OH minus, right? And then in your ice diagram is 0.2, 0, 0. So this one minus x, x, x. So at equilibrium is 0.2 minus x, x, and x, right? So you get your value of x, which is equivalent to the value of your OH. So since you have the value of OH, so you can get the POH equivalent to negative log OH minus. So the value of X that you get just now is 0.9487. So you should get your pOH equivalent to 0.0229. So this is your pOH. But in the question, you were asked to calculate the pH at equilibrium, right? So the pH of it, so pH plus pOH is equivalent to 14. So your pH is 14 minus your pOH, which is this one. So 14 minus 0.0229, you should get 13.9771. So this is your final answer for this question. Okay, this is the last question. Question number 5, the easiest among all these questions, I suppose. What is the pH of 500 ml of solution containing 0.0124 gram of CaOH2? Okay. Simply when you have your mass, you need to calculate the number of mole. So number of mole for CaOH2. Okay. Number of mole equivalent to mass over RMM. Okay, your mass given in the question is 0.0124. So 0.0124 divided by the RMM. So you have Ca, which is 40.08 plus your OH. You have two of those. So 15.9994 plus the H is 1.0079. So you should get the number of mole for CaOH2 is equivalent to 1.6735 times 10 to the power of negative 4. Right, this is the first step. And then from here you can see that in the question given to you, the volume is actually 500 ml. So 500 ml. So you have the number of mole, you have the volume, so you can grab the molarity. So molarity equivalent to mole over liter. So mole is this one. Just bring it. Right? 1.6735 times 10 to the power of negative 4, and the volume is 500 ml. So divided by 1000 because you want to convert it to liter. So you should get the molarity equivalent to 3.347 times 10 to the power of negative 4. Right. This is the molarity. So molarity of what? Molarity of CaOH2. So is this thing an acid or a base? So obviously it's a base. We have OH around here. So although the question asks you to calculate the pH, right? But you should know that this is not an acid, this is a base. So you should calculate the pOH beforehand. So pOH equivalent to negative log OH minus. So the molarity of this is negative. Just bring it. So it's going to be 3.347 times 10 to the power of negative 4. So you should get your pOH equivalent to 3.1743. Okay, this is not the N because you still need to calculate the pH. So pH plus pOH equivalent to 14, and then pH equivalent to 14 minus pOH, where this is your pOH. So 14 minus 3.1743, you should get your final answer 10.8257. Alright, So that's all for this week's discussion. So we'll see you again next week virtually. Thank you for watching this video till the end, and please do subscribe and press the like button. So see you all next week. Thank you very much. Goodbye.